There are also typically inductive argument forms that we can use to more easily identify inductive arguments. Remember, inductive arguments are based on probabilistic reasoning or probabilities. The content of the conclusion in some way goes beyond the content of the premises. So for example, a prediction. So if a prediction is an argument that proceeds from our knowledge of the past to a claim about the future. So if I said, for example, because certain meteorological phenomena have been observed to develop over a certain region of central Missouri, a storm will occur there in 6 hours, or really any weather forecast at all. We know that those are only probabilities. Meteorologists are using their knowledge of what has happened in the past when certain weather systems and conditions have existed at the same point in time, and they try to take that knowledge of the past and apply it to a future circumstance. But as we well know, meteorologists, weather persons, are not always accurate. So best treated as inductive, right? Best treated as a probability and not a certainty. Because everyone realizes the future cannot be known. And so when an argument makes a prediction about the future, you're usually justified in considering it inductive. An argument from analogy is considered inductive because it depends on the existence of a similarity between two things or between two states of affairs. And they're trying to take the information from one of those things and apply it to another, where it probably is the case that you can do that, but it's not necessarily so. So if I said, hey, Christina's Porsche is a great handling car, so it follows that Angela's Porsche must also be a great handling car. Is that probably the case? Sure. If Christina and Angela both drive Porsches, there's a great likelihood that both of them are great handling cars. But I also don't know enough. We don't know enough about Christina's Porsche and Angela's Porsche to know if that similarity holds any weight. There's no certainty. One car could be much older than the other, in a completely different condition, etc. So it's best treated as an inductive argument. Is it probably the case? Yes, but is it necessarily the case? No. So if it involves probabilistic reasoning, it's going to be inductive. A generalization is also considered a typically inductive argument form, because you're taking, what a generalization really is taking information from a selected sample of people, things, etc. in a group, and then applying it to the whole group. So because the members of that sample have a certain characteristic, people want to argue that all members of that group have the same characteristic. So if I said, I took 3 oranges from this crate of oranges and I tasted them and they were especially tasty and juicy, I'm going to conclude that all the oranges from that crate are especially tasty and juicy. But when you're talking about oranges, sure, you could say that's probably the case, that if I tasted 3 oranges out of a crate of orange and they were oranges and they were all tasty and juicy, that the rest of the oranges in the crate will be tasty and juicy. But I'm not assured of that. Someone could have put 3 really nice oranges on the top of the crate and filled the rest with really terrible rotting oranges. Someone might also try to make an argument about people and say 6 out of a total 9 members sampled from a certain labor union intend to vote for Johnson. So therefore 2/3 of the entire membership intend to vote for Johnson. Well, you can't take 9 people out of an entire labor union of we don't know how many people and say, well, that's 2/3 because we interviewed 9 people. This is also why statistics are usually considered inductive. Okay, then the next one is an argument from authority. This is an argument that concludes that something is true because a presumed expert or witness has said that it is. So a lawyer might say, Mac the Knife committed the murder because an eyewitness testified to that effect under oath. But the eyewitness could be mistaken, they could be lying, you're depending on people and you're depending on their expertise, which is not necessarily correct expertise or dependable expertise. So arguments based from authority are usually considered inductive. Is it probably the case that an eyewitness saw something? Maybe so. But is it necessarily the case? No, because the eyewitness could have all sorts of problems with perception, or they could be lying, they could have a reason to put out false information, etc. The next typically inductive argument form is an argument based on signs, and they mean actual signs, not omens or like a sign from above. They mean written communication. So an argument based on signs is an argument that proceeds from the knowledge of a sign to a claim about the thing or situation that the sign symbolizes. So if I was driving down the highway close to where I grew up in Abbeville, you might see a sign pretty frequently that looks something like this, and it has an arrow at the end of it, and you say, okay, I know what that means. That means that there is a curvy road ahead and I need to maybe slow down or pay more attention, etc. But this sign, this visual message or written message produced by an intelligent being, I might say that, look, because I saw this sign, it means that there are several sharp turns, ahead. But maybe the sign is misplaced. Maybe it's in error about the turns. Maybe someone has put it there to trick you. Because of all these reasons, is it probably the case that when you're driving down the road, you can depend upon signs being accurate? Sure. But is it necessarily the case? No. So because it involves probabilistic reasoning, it's going to be typically inductive. A causal inference is also typically treated as an inductive argument form. And it's an argument that proceeds from knowledge of a cause to claim about an effect. So it's saying, well, if I know the cause, then I can tell what the effect was. Or it could go the opposite way. If I know the effect, I know what the cause is. But that's not always dependable. It's not necessarily the case. So I can't say that because I have knowledge of a cause, I know what the effect is, or with any real certainty that if I know the effect, I know what the cause was. So for example, if I know that a bottle of wine had been accidentally left in the freezer overnight, someone might conclude that it had frozen. Well, sure, wine has for those of you who have worked as servers or bartenders, you might know that wine has a lot of water content, and it in fact does freeze. So the cause, putting it in the freezer, we can conclude that the effect is that it's frozen. But as you also might know, other types of alcohol are not always the case. It's not always the case that they freeze. So harder alcohols, harder liquors don't freeze. So you couldn't say, I know the cause if I left a bottle of, vodka in the freezer, that the effect will be that it's frozen. Also, if I said something like, here's a piece of chicken, I find it to be dry and tough. So that's the effect. I'm going to conclude that the cause must be that it's been overcooked. But there are other things that could have caused that chicken to be dry and tough. For example, it could have just been left out on the counter for weeks. Or I don't know, it could have been made into beef jerky. Who knows? There are a number of things that could have happened to the chicken. So because specific instances of cause and effect can never be known with absolute certainty, we can never really know if a specific cause led to an effect or vice versa, we usually interpret these as inductive.